So here's the summary and the diagrams for what I just did. So in the first case, when there is only one asset, one risky asset and one risk-free asset, what we did is we basically construct a budget line like this, which is the connection between the risk-free asset and the only risky asset. And then we have a utility function that shapes like this. But the direction of going up is different. It's going up in a way such that we want to increase the return and reduce the risk. And then we just keep moving this thing up until it hits the highest possible utility level, and we call this portfolio the optimal portfolio. And the proportion of this portfolio that's invested in the risky asset, we call it beta star. And in the next case, where there are two different assets, what we did is basically we combined the two assets first. So the way to do it is, suppose we invest everything in asset A, then we're at this point. Then as we decrease the proportion we invest in A by little amounts, then we basically construct a line of different portfolios. And if we invest everything in B, we hit this point. And of course we could borrow A or B, so we could actually theoretically extend those lines. And then the next step is basically we would like to combine the risk-free asset with a combination of these A and Bs. So what we had is the highest it can reach is this, but then it can combine anything as well. So there are actually infinite number of combinations that's possible. So basically, I should draw it like this. So everything within this big triangle is possible. But then, since we want to maximize a utility function like this, we know that it's going to hit this upper boundary. So what we did is basically highlight this upper boundary. So there's one particular combination of A and B that we are particularly interested in, and we call this F star in A and 1 minus F star in B. I think it's actually reversed. It should be F star in B and 1 minus F star in A. And this particular one is investing a combination of A and B only and no risk-free. But then if we connect these two lines, we get the boundary of this set, which contains all possible combinations of A, B, and risk-free. And then we just maximize utility with respect to this red line instead of the whole set, which is more difficult to do right now. And then we call this one the optimal one. So for this one, we just have beta star proportion in this optimal portfolio constructed by only A and B, and the rest in risk-free. And the last case is the mean variance case. So just like what we did, we construct this combination of A and B first. But what we notice here is there is actually one single portfolio, one single combination of asset A and B that has the minimum variance. So this is the mean variance portfolio. And then we combine these two. And then we still maximize the same utility function like this. So we hit the point like this, like here. So what we do is we call this one F star in B and 1 minus F star in A. And again, we have, say, beta star invested in this combination, which is the mean variance combination, and the rest in the risk-free asset. So that will be a summary of all these three cases.